Hey guys, my name is George and I'm a Phoenix FD product specialist at Chaos Group. In this video, we'll go over the new features inside of Phoenix 4 and how you can use them to improve and speed up your workflow. Let's start with active bodies. With active bodies, we have introduced basic rigid body simulation with Phoenix Liquid. So far, in Phoenix, the fluid simulation could be affected by moving obstacles, but the fluid could not affect the obstacles back. And with Phoenix 4, flip liquids can now influence the movement of obstacles that are marked as active bodies. In simple words, this means that objects such as boats can now float over Phoenix FD ocean simulation and be affected by its waves. Floating debris can be really easy to set up compared to previous particle flow workflows, and objects placed on the ground can be washed away by flooding waters. Let's take a look at how this works in practice. And I'm going to open a new scene, and in here I have prepared a simple crate model that's just an extruded box with a few textures applied. Then I have created a basic liquid simulator in here from the Phoenix toolbar, and in order to create active bodies, let's create the active body solver from the toolbar here. Let's go to its settings, and in here you can use the active body solver to control which body will be made active bodies and how the liquid simulation will influence those bodies. So in here, let's add our crate and start the simulation. As you can see, nothing happens. That's because we need to link the active body solver to the liquid simulator. So let's select the simulator and let's go into the dynamics role. And in here we have active bodies checkbox. So let's turn this on and let's pick our solver. And let's start the sim again. And now you can see that our body starts falling, but it's falling to infinity. So let's stop the sim. And you can see that a blue box appeared and a smaller box appeared in here as well. So what is this blue box? This is our original crate, and this is our Phoenix clone. And in here, you can notice that if I select the object to its name, it's appended Phoenix clone. So that's how we know that it's our cloned object. And in here, you can notice that some keyframes appeared. So this is the motion of our active body. It's being baked to keyframes. So even if I scrub the timeline, the animation stays, and if I select my simulator and even delete the caches, the simulation of the active body will be still there. And why does our original object looks like this? It has been converted to be displayed only as a box, so it's easy to distinguish between the original and the clone. But if you go into the object properties in here and turn off the display as box, you will notice that it's exactly the same object. So let's turn this on again. And what this is our center of mass. So if we want our body to be heavier on one side, we can move this and it will start turning to one side. Okay, so our body is falling, but it's not interacting with liquid. So let's turn on some liquid. I'm going to turn on the initial fill up from the dynamics role of our simulator, and let's start the sim again. Okay, now as you can see, our active body now interacts with the liquid, but it goes straight to it. And that's because it's way too heavy. So let's select our body, the original one, and right click and select the Phoenix FD properties menu. In here, we have some active body options where we can specify the mass or a density of an object. And in order to be a little bit easier, we have created some presets in here. And if you notice, by default, it's using concrete, but this is a bit too much. So let's go and switch this to cork. And I'm going to press OK. And let's start the sim again. Okay, let's stop the sim. And as you can see, now the active body enters the liquid and it starts floating on the liquid surface. Okay, so far so good, but what if we want a few active bodies to float around? Let's shift drag. Oh, okay, let's shift drag our original object, and this will create a copy. And let's go to the active body solver and pick the crate again here. And let's select those, move them a bit like this. And let's start the sim again. Okay, now as you can see, our both crates are floating over the liquid surface, but you will notice that they're not interacting with each other. Currently, Phoenix 4 does not support collision between active bodies, but this is something that's definitely coming in a future update, so stay tuned for the future updates of Phoenix 4. Okay, I'm going to open another scene. Okay, here we have an already simulated speedboat that is moving through the waves, but as you can notice, it doesn't react to the movement of those waves at all. It just goes straight forward. So let's make the boat an active body. I'll create an active body solver. Then I'm going to add the speedboat. Then I'm going to select our simulator, and from the dynamics rollout, for the active bodies, pick the active body solver. Then let's select the boat, right click, and from the Phoenix FD properties, let's change the default density. So we have ship hull. That's a bit close, but I think ship is a bit bigger. So let's go with 400, for example. And let's start the simulation. Okay, let's stop the sim, and as you can notice, the original starts moving, but our Phoenix active body stays on one place. And as you can see, it's a bit heavier in the front. So let's delete the clone so it doesn't get in the way. And what we can do is we can move the center of mass a bit back, like so. So this way, it won't be so heavy at the front. Just make sure that when you go to the Phoenix FD properties, you have the override center of mass turned on. And what about the animation? So we have this option, which is called original animation influence. When this is set to 1, the active body will follow exactly the animation of the original. And if it's set to 0, as in our case, the animation will be ignored. And as we want our boat to be affected by the waves, but still to follow the animation of our original, let's set this to 0.05. Press OK, and let's start the simulation again. And now, as you can see, our boat is floating over the waves and it's following the original animation of the speedboat. And using the original animation influence is a great way to blend between the animation of an object and the fluid interaction. So you could get the best result out of the two. Okay, let's go and check another scene. In the next scene, we have a liquid simulator that is filling with water, and we have some cubes. And what we would like to do is when the water hits the cubes, like so, we want the cubes to start rolling and to be swept away by the water. So let's do it. I'll create an active body solver. Then let's pick our cubes, then select my simulator. And in the dynamics rollout, let's pick our active body solver. Then let's start the simulation. As you can notice, our cubes will start to falling into the abyss. So what we're missing is some ground. Let's go into the create panel, and in the standard primitives, let's create a plane. Then what we can do is select our active body solver and turn on the ground plane checkbox and pick the plane we have created. Then this plane will act like an infinite ground plane for our active body simulation. And in here, using the ground friction and ground elasticity, we can control how the ground will affect our objects. And increasing the friction will prevent sliding, while increasing the ground elasticity will make the objects bounce from the floor. In this case, the default values should work just fine. And let's start the simulation. Okay, and now our cubes will stay static, and when the liquid hits them, they will be swept away by the water. So using the ground plane is a great way to create some flooding scenes. Okay, that's for the active bodies for today, and let's go to the next scene. Okay, for the next scene, we're going to be using the burning chair from our tutorials page. And if you go to the Phoenix FD docs page, we have quite a lot of tutorials and we're constantly adding more, so make sure to check those out. And I'd like to show you another new addition to Phoenix 4, which is the voxel tuner. It affects the voxels of the Phoenix FD simulator, giving you finer control over fire, smoke, RGB, and the rest of the grid channels. Using it, you can procedurally create smoke and temperature even without using sources, just by using the voxel's velocity or distance to a certain object. So let's see how this works in practice. I will create a voxel tuner in here from our toolbar. And by default, we have a condition in here, which states that if temperature is above 800 degrees Kelvin, then increase the temperature by 1 degree in every cell. What the voxel tuner will do is it will go all over the grid cells and check if the temperature is above 800. And when this is the case, it will start to increase the temperature by 1 degree for each simulation step. Okay, so that sounds a bit boring, so let's do something more practical. What I'm going to do is change the action to the smoke and set it to 1. Then what this will do is whenever we have temperature above 800 degrees, our voxel tuner will start to emit smoke in those cells. So let's start the simulation. Okay, now we can see that we have smoke, but it's all over the place. And what if we want the smoke to be born in a certain distance away from our chair? So let's open the edit condition window. So in this window, we could choose between different operations like is greater than, is less than, or is equal to, and then we can choose between different grid channels. You can see all the available channels. We can use distance to a certain object or use the texture intensity to modify the conditions for our voxel tuner. So let's collab this condition, and I will press this and new comparison. This will create an AND operator and a new comparison. So this means that when both of these conditions are met, the voxel tuner will start doing its magic for that particular voxels. And for voxels where the condition doesn't pass, nothing will change. So let's click on the temperature in here and let's change it to distance 2. Then let's pick our chair and let's say 30. Then our condition will check if the temperature is above 800 degrees and if the distance to the chair is greater than 30. If both of those are true, then we'll have some smoke. So let's check how this looks. Okay, so now we have some smoke created away from the chair, but as you can notice, there is quite visible border in here and the smoke is way too dense. So in order to get rid of the border, we need to randomize the distance to the chair a bit. So let's open the edit conditions window, and for the distance in here, let's check the random between, and let's try a value between 20 and 30. As for the too dense smoke, we can use the build-up time option in here for the voxel tuner. If I set this to 1, this means that when these conditions are met, the smoke will start to gradually increase as time passes, and after 1 second, it will reach a density of 1. And as by default, max is using 30 frames per second, so 1 second means 30 frames. That's how you can calculate how your simulation will look in frames. So let's start the sim again. Okay, so now our smoke emission is randomized, looks much better, and the density goes gradually, so it looks a lot more natural. The next cool thing that I'd like to show you with the voxel tuner is that you can duplicate. So if I shift drag my voxel tuner and create a copy, this will duplicate the conditions as well. So this way, we can use the same conditions but do something entirely different. In this case, let's make our smoke green. For this, I'm going to change our then action, and I'm going to set it to RGB green and set this to 1. And in this case, as we want the smoke to turn green instantly, set the build-up time to 0. The next thing that we need to do is select the simulator, go into the output role and make sure that the RGB channel is exported. Then for the rendering, let's go to the volumetric options, and for the small color, let's choose RGB. Let's start the sim. Okay, and now our smoke turned green, and we did it using the voxel tuner because we're creating smoke without actually using a Phoenix source. So this way we can have the smoke color set at the moment the tuner creates it. In here, we can notice that our simulation gets clipped. So what we can do is enable the adaptive grid, which will automatically resize our container based on the contents of our simulator. So let's set this to smoke, and using the maximum expansion in here, we can control how far our grid will expand. But another cool option that you can use is this little checkbox in here, shrink to view. And in here, if I click on this select button and pick an object, we can pick our camera. So this way, our grid can expand only in the frustum of the camera. This way we could save some simulation time and memory, as we'll simulate only the parts that the camera sees. And now, if we start the simulation, the grid will expand together with our sim. Okay, so now our smoke expands according to the smoke, but what if we want to change the color of the smoke only in a certain part of the simulator? So what we can do is, let's create a box, like so. Let's position box in here. And let's say that we want our smoke to turn blue only where this box is. Okay, so I'm going to select our box, go to the object properties, disable the renderable checkbox, and turn on display as box. This way we'll be able to see what's going on inside of it. And then let's go to the Phoenix FD properties and disable the solid object. This way, this box, it won't obstruct the temperature and the smoke. So I will select my second voxel tuner, shift drag to clone it, press OK. Then from the edit conditions window, I'm going to select my AND operator, and I'm gonna replace this with a new comparison. So this will delete all of the old stuff and create a brand new. So let's change the temperature, and we want to use the distance to our new created box. And let's say if the distance is less than, and let's say 2. If the distance to the box is less than 2 voxels, then let's turn our RGB to blue. And as we don't want to have a visible border around here where the effect's starting to take place, so let's increase the build-up time to 0.2. And let's start the simulation. And now we have created some smoke, and it's green, and as soon as it reaches our guide box in here, it starts turning blue. Okay, so let's go and check the next scene. In the next scene, we have this simplified model of a spaceship landing on the surface of a distant planet. And let's see how we can simulate some dust coming out of the ground as the spaceship moves near it. So one way to do that would be to use the ground in a Phoenix source and animate the discharge as the spaceship lands. But this way of doing it is a bit rigid. If the animation of the ship changes at some point, we'll have to redo the keyframes in the source, and if the animation is complex, this might take some time. While using the voxel tuner, we can take a more procedural and future-proof approach to getting the desired result. So let's see how I can do that. I will create a voxel tuner in here. And let's start our simulation. And as we want our spaceship to be the driver to the simulation, let's go to the edit condition window, and instead of temperature, let's use the distance to our ship. And as 800 seems a bit way too much, let's set this to 20. And then let's set our action value to 1, and we want to create smoke. Now, this way, when the distance to the ship is greater than 20 voxels, it will fill the simulator with smoke, but we want to do the exact opposite. So let's change this to is less than, and let's restart our simulation again. And we can see that we have smoke created around the ship, but we want the smoke to be created around the ship and only near the ground. So let's stop the sim for now. Let's go to the edit condition, and as we want the ground to participate again, let's select the is less than operator and create this and new comparison. Then for the another condition, we can use the distance to the ground in here, and as we want to be really close to the ground, let's pick something like 3 voxels and change the is greater than to is less than. So what this means is the smoke will be created only where the distance to the ship is less than 20 voxels and the distance to the ground is less than 3 voxels. So let's start the sim. Okay, so now the smoke appears only on the ground where the ship is near, but it stays like a solid spot and it's not rolling around nicely like a proper dust simulation should do it. So let's see how we can do that. If we make the ship move faster, this will push the smoke more and it will look more natural. But what if we like how our animation looks right now and don't want to change it? So what we can do is I'm going to select our ship, right click, and go into the Phoenix FD properties menu. And in here, we can change the motion velocity effect to 10. So this way, our simulator will perceive that our ship is moving 10 times faster. And now, if I start my simulation again, now the smoke starts rolling out nicely. Let's select our simulator, and in here in the preview, I'm going to disable the auto reduction and set this to the detail reduction to 0. Now we can see our result a lot better. You can see that we get this really nice rolling motion of the smoke. Okay, this looks cool, but it's way too uniform. So let's add some randomness. So what we can do is select our voxel tuner in here. Okay, and let's change the distance to the ship to be a random value between 0 and 20. Then what we can do is to make the smoke appear only where the velocities are high enough. But how do we find out in what range our velocities are? So let's go into the output route first and make sure that we have velocity exported. This way we can use them. Then in the simulation rollout, we can see that the velocity channel is from 0 to 205. So we already know that this is the range we could use. But if we go into the preview window and if I disable my smoke, I can turn on the velocity. And in here, I can play around with the ranges. This way, we can see how the velocities look in a specific range, and we can pick the right values for our voxel tuner simulation. So let's disable the velocity, turn the smoke back on, and let's go back to our voxel tuner. Then I'm going to collapse these conditions in here, and let's create a new comparison. I'm going to click on the AND operator and create this AND new comparison. Then, as we want to use the speed, let's go and pick the speed channel, and I liked the range between 35 and 60. So if we start the simulation again, okay, now our simulation looks a lot more random compared to what we had before. You can see the alt caches we had at the start. Now it looks like this, a lot better, but we could add even more randomness in here. So what we can do is select this AND operator, and let's create a new comparison. Now we can choose a texture intensity. So we could use a texture to add even more randomness to some places. So let's go and click on the no map, a nice texture in here, open the material editor, drag the texture in here, and for the size I'm going to set something like 100, make the noise fractal, set the high value to something like 0.7 and the low value like something like 0.3. Then let's change the value in here to be a random value between 0.2 and 1. This way, if all of our previous conditions are met and the places where the texture intensity is in the specified range, our smoke will be born. So let's start the sim and see how this looks. Okay, so this is looking much better compared to the previous one. And we have created the setup in a totally procedural way, so if the animation changes at some point, the simulation will adapt, and it will still work without the need of manually adjusting keyframes at all. The voxel tuner gives you amazing control over your grid channels such as temperature and smoke. But what if there are particles in the scene and we would like to have the same control over them? Okay, that's why we created the particle tuner. So let's go and open the next scene. The particle tuner is a tool that gives per particle control which wasn't possible before in Phoenix 3. It goes through all particles in the simulation and changes their values if they pass a certain condition, just like with the voxel tuner. But instead of the grid channels, it will affect the particles. So let's take a look at how this works. In this scene, I have pre-filled a cocktail glass with some blue liquid. And if you want to find out how to pre-fill your glass at the start of your simulation, just go to our tutorials page in the Phoenix FD docs and you'll find out the tutorial how to use the initial liquid fill. So in the scene, we have this cylinder that is added to the liquid source and that's emitting some red particles. And I have made them red by using the RGB checkbox in here and set the color to red. Then for the simulator, in the dynamics rollout, I have used a blue color for the default RGB. And just a note, if you want to use the RGB channels, make sure that in your output rollout you have exported the RGB for the particles and for the grid channels before you start your simulation. Okay, so the next thing is the RGB diffusion. In this scene, I have set it to 0, so this way our colors won't mix. But if I go a bit ahead of time, you'll notice that our red particles are scattered through the blue ones. And for the purpose of this tutorial, we wanted to make the red ones appear heavier and pull at the bottom of the glass. So how can we do that using the particle tuner? Let's create one. But if I go into my toolbar, you'll notice that there is no particle tuner present. In here, you will notice that there are some icons with white arrows at the bottom. What this means is that there are more icons if you hold down the left mouse button. And our particle tuner is hidden in here, and there are more icons for the forces and even for the presets. So if there is a white arrow, just hold down the left mouse button and additional icons will show up. So let's create a particle tuner. And we can see that its user interface is really similar to the voxel tuner, but the options are a bit different. We can specify which particle groups to affect. In this case, by default, it's liquid, but you can choose foam, splashes, mist, or drag particles from the fire and smoke simulator. Then we have our condition box and the action panel where we can choose between deleting the particle or changing some of their properties. Okay, by default, the condition is if the h of the particle is greater than 1 second, then increase the viscosity by 1. Note that the h in the particle tuner is in seconds and not in frames. And if you want to have the channel as our condition, make sure that you go in your simulator output rollout and you have the h exported for your particle systems that you want to use in the particle tuner. Okay, so in our case, we want to separate our particles on their color. So let's select that is greater than option and create a new comparison. And we want to separate the red particles. So let's pick the RGB red channel. And for the value, let's say 0.5. Now let's change the action. Instead of viscosity, let's pick velocity Z. This way we can change the velocity in the Z axis. Note that this is the vertical one for the Phoenix fluid solver in both Max and Maya. And if we decrease this with some large number, the red particles in here have nowhere to escape because they're trapped by the glass, and they will stay at the bottom and push the blue particles upwards. So let's select our voxel tuner and change the action to decrease by, and let's use something like 600. Okay. If I select our simulator and go into the dynamics rollout, you'll notice that my steps per frame are set to 2. And when our steps per frame are above 1, as in our case, and in the particle tuner, the build-up time is 0, this means that our action from the tuner will be executed for each step. So our particles will have their velocity decreased 2 times each frame. In this case, this will make the liquid way too turbulent instead of the red particles gently going downwards at the bottom as it happens with real cocktails. So let's set the build-up time to 0.1. This way, when our conditions are met, our velocity will be decreased by 600 after 0.1 seconds. In this case, we're using 30 FPS, so divided by 10, this makes 3 frames. As we're a bit tight on time with this demo, I'm going to change this h to 0.4 instead of 1. This way we'll get a quicker result. And let's start the simulation. Okay, and now as you can see, the red particles are starting to pull at the bottom of our glass. And if I scroll how it looked before, you can notice that the red particles were scattered through the whole glass, and now they're starting to pull at the bottom. So to recap, what we did is when the edge of the particle is greater than 0.4 and the RGB red channel is over 0.5, then we'll decrease the velocity by 600 after 0.1 second. Okay, so this is how we can use the particle tuner to control our particles, and using the particle tuner provides a really convenient way of controlling particles coming from different sources. So you can just assign a different RGB color for each source and then use the conditions to mix and divide those particles. Let's take a look at another example of how we can use the particle tuner. Okay, so I'm going to open the next scene. I have used this Christmas tree as an emitter for our liquid source, and if I start the simulation, you'll notice after a few frames how our tree looks like. Okay, let's stop the sim and let's create a particle tuner. Using the particle tuner, we can change the particle viscosity after a certain period of time has passed. So this makes it really easy to create directable melting or solidifying effects. So let's see how to do that. In the create panel, I'm going to create a sphere like so. Let's go and position it close to our tree. So something like this. Okay, and let's make it a bit smaller, like so. Let's make sure everything is where it needs to be, and let's change some settings. Right-click on the sphere, and in the object properties, let's make it non-renderable and display as box. This way it won't get in the way, and we'll be able to see what's going on inside. Then from the right-click menu again, go to the Phoenix FD properties and make it non-solid. This way it won't interact with our liquid particles. And for the particle tuner, let's edit our conditions a bit. As we want to use the distance to the sphere, let's go and change this to distance and pick our sphere. And as we want to affect only the particles that are really close to the sphere, let's change this to is less than and set the distance to something like 5 voxels, for example. Then for the action, we want our viscosity to be set to 0 when our sphere is close. So let's see how this looks. I'm going to move away the sphere at the start so we can have some solid tree. And if I move my sphere, okay, let's stop our sim, and you can notice that whenever our sphere is close to the tree, it will decrease the viscosity and start to melt our tree. Another cool trick that we can do is let's shift drag our particle tuner and make a copy. And this time I want the distance to be greater than, and let's say 10. Then I want to set my viscosity to 1 and set my build-up time to 0.5. This way, when the first tuner will melt the particles, and after a certain period of time, the second particle tuner will kick in and it will solidify the particles again. So let's see how this looks. I'm going to delete those caches, and in order to be able to see what's going on better, let's turn on the show mesh preview and turn on the particle preview. Then I'm going to scale the core by viscosity, and let's start our sim. Then if I move my sphere in here, it will make the viscosity lower. Then it will color the particles in black. And as you can see at the start, the particles will melt from the first tuner, and as the sphere gets away from them, they will start to solidify again over time because we have used the build-up time of the second tuner. Okay, let's delete the second tuner as we won't need it anymore, and let's turn on our mesh preview again. Okay, another cool thing that you can do with the particle tuner is to delete particles. So let's switch our operation to delete particles and start our simulation again. And now, whenever I move my sphere, it will delete some particles and it will look like our Christmas tree gets eaten out. Okay, let's stop the sim. This way we can delete particles based on the position of a helper, but we can delete them using a lot more complex condition as well. Let's say we want to delete the green particles with an age greater than 0.2 seconds and moving with a speed over 80. So what I can do is let's create another particle tuner node and let's edit some conditions. Let's go and change the age to RGB green. Then I'll select the is greater than, and I'm going to add another comparison. Then let's change if the age is greater than 0.2. And then I'm going to add another condition. And this one will say if the speed is greater than 80. Then I'm going to set my action to delete particles, and if I select my liquid source, I will enable the RGB channel. And I have already created a colored noise map for the RGB, and let's go in our output settings, make sure that the RGB channel is enabled, and let's go and turn off the show mesh preview, and let's change our color to speed. Then if we move our sphere, oops, so let's change the viscosity in here for the first tuner. So this way it won't delete particles. And if we move our sphere closer, oops, so we need to change our condition in here to be greater than 0. So let's start the simulation again. Let's generate the particles at the start so they can be a bit solid, and let's move in our sphere in here like so and make the particles melt. And you can see that after 2 seconds have passed, the green particles disappeared and the red ones are in here. This way, you can use the particle tuner to build really complex solutions to affect your particles. Okay, I will delete my second particle tuner as we won't need it anymore. Let's delete the caches in here and move our sphere to the side. And let's go and turn on our mesh preview again, disable the particle preview. And what I want to do now is go and turn on my default shading. Let's start the simulation now. And you'll notice that I have already applied a material with a checkerboard texture to our tree, but it looks like nothing like it should. So in order to fix that, we can use the newly introduced in Phoenix 4 Text Uvw channel. So let's select our simulator and go into the output rollout. Then make sure to turn on the texture Uvw channel for both the particles and the grid. And then in the liquid source, in here at the bottom, we have this checkbox that says inherit the text Uvw from the geometry. And now, if I start my sim, you will notice that we have proper UVs for our liquid. And another cool thing is that in here for the object, I have a few Uvw Map Modifiers. And for the first one, I have set a map channel of 1. And for the second one, I have assigned a map channel of 2. So if I go into my liquid source, you'll notice that we can specify map channel in here. So I can choose map channel 2 because I have already created it for my object. And then if we start the simulation, you'll notice how our texture now is mapped differently because it's using the another UV set. So this way you can have multiple UV sets for your object and use the right one for your simulation. Then another thing we could do is if we start our simulation and move our sphere in here to melt the particles. And now you can see that whenever our liquid starts to melt, our texture sticks to it and starts moving properly with the fluid. And the cool thing about this technique is that if I create a new checkerboard texture and give it some tiling and plug it in here, and as you can notice, it gets properly distorted. And this way we can adjust or completely change the texture of the fluid without having to simulate again. The great thing about the text Uvw channel is that it not only works with liquids, but works with far and smoke simulations as well. So let's take a look at how this works. Okay, in the next scene, we have this large-scale smoke simulation that I have already prepared and simulated. And in the output rollout, I have enabled the texture Uvw channel. And in the simulation rollout, we can see that it's simulated and present in the caches. And why this is important? Until now, you could use textures for color, opacity, and displacement, but if your volume or liquid was moving, the texture stayed on one place while the fluid swam right past to it. And using the text Uvw channel, now the texture will be able to stick and move together with the fluid. And this is really useful when you like how your simulation moves, but you feel that it needs a bit more detail. Of course, you could use resimulation, but this will take additional simulation time and it will consume more memory. So what you could do instead is to add a texture to modify the color and opacity, or add the needed detail through displacement. And when our text Uvw channel is present, then the assigned textures will flow organically with the fluid. So let's open the VFB and you can see how our clean smoke looks like. I have lowered the render settings so we get quicker renders because we are a bit tight on time. So this is how our smoke looks like. Let's go into the rendering rollout and go into the volumetric options and open the small color panel. In here, I have already plugged a noise texture. That's just a regular noise texture. And if I open my material editor, you can see how my color noise looks like. When using the text Uvw channel, make sure that your coordinates are set to explicit channel. This way, the textures will be mapped correctly. And let's see how it looks. You can immediately see that we get a lot more detail in the smoke. And if we save our image in here, let's say colored smoke, and compare it to before, we can see that we get quite a lot more detail. Looks like I have rendered the frame before. Okay, so let's go to frame 113 and do a render, so our comparison will be fair. Save the image and cover smoke. And if we compare it, now you can see that we get a lot more details in here and in here, but the color changes. What if we like our color, but we still need more detail? Of course, we can disable the texture in here and we could modulate the opacity. So I have did the same exercise, plugged again a noise texture for the opacity, and let's take a render and see how this looks. Okay, not bad, not bad. Let's save this and let's give it a name. And if we compare this one to the first one, we can see that we get a lot more detail in here as well. But as you can notice, the scattering of the smoke changed quite a lot. And let's say that we still need more detail, but we don't want to change the scattering of our smoke. Then we can use displacement. So let's disable the texture for the smoke opacity, go into the rendering rollout of our simulator, and in here we can enable the displacement. In here I have plugged another texture. Again, I have used a regular max noise and I have increased the multiplier to 2, so we can get a bit stronger result. And let's take a render and see how this looks. Okay, let's save this image and give it a name. And let's compare it to the first one. You can see that immediately we get quite a lot more detail without changing the color or the opacity. So our scattering stays the same and the smoke gets a lot more detailed in here. Though you can notice that our render time increased quite a bit, from 11 seconds to 42 seconds. So depending on the result you're after, you can choose between color, opacity, or displacement texture to get the best result possible. And combining this with the text UVW channel, your textures will stick to the fluid and you'll get some natural looking results. Let's get to the next example. I'm going to reset the scene for this one and start from scratch. And now I'd like to show you our newly introduced operators for thinking particles. And you can use them to create and influence TP particles based on the data coming from Phoenix FD simulation. Let's go and take a look how this works. I will create a simple sphere and add a fire preset to it. Then let's go and decrease the resolution a bit so we get faster feedback. And let's go into the output rollout and enable the velocity channel. We will need it a bit later. So let's start the sim and see how it looks. Okay, let's stop the sim. And if we scrub our timeline, this is the result that we get. A bit low res, but it should get the job done. So let's create some particles. I will go into my particle systems menu and let's create thinking particles. Then let's go into their properties, and from the master dynamic I will create a new dynamic set. if I right click in here from the operators menu, there is a new Phoenix FD submenu from where you can select our new our new Phoenix operators. So let's start with the board. If I select it, it will ask for a Phoenix node. So let's pick our simulator and let's go to the first frame. And if I start increasing the frames, you will see that we have some particles created. Let's select our simulator, and in the preview I will turn on only if selected. This way, if I deselect my simulator, I won't be able to see the preview and it won't get in the way. Though if I need it, I can select my simulator and my preview will be there. So what does the Phoenix FD BERT operator does? It creates particles based on a certain channel of our simulation. So you can create particles based on the temperature, the smoke, the speed, or the fuel. And using these curves in here, you can control the range where those particles will be born. I'll disable the smoke, as in the simulation we have no smoke, and the default graphs work just fine. So let's deselect our simulator, and those particles are a bit too much. So let's set our particles to 2000, max 2000 particles per second. Let's go to the first frame, and now if we move the timeline, we see that our particles are born where there is fire, but they're staying in one place. So what we can do is let's create another set, and in this one let's go to groups and pick on the all particle group, because by default our particles are going there. And then let's create another Phoenix FD operator. Then let's create the Phoenix TP force and connect our particles to the particle input. Then for the TP force, we need to pick our simulator. And if we go to the first frame, now when we scrub, our particles will move together with the simulation. In order for this operator to work, you need to have the velocity channel exported in the output in here. So that's why we enabled it at the start. So what the TP force does is it affects the movement of the particles using the velocity data. And it's really useful when you want to give your particles an interesting motion pattern or add more variety to your effects, such as disintegrations or destruction scenarios. Okay, so let's see how our third operator works. I'm going to open another scene. Okay, in this scene, we have a pretty basic Phoenix FD explosion in here. And let's go and open our scene explorer, and let's go and turn on our thinking particles in here. So I have created a few cubes and instanced them via thinking particles. And what I'd like to do is when the explosion happens, I want my cubes to start flying around. So let's go into the thinking particles properties, and in here I have the particle group, the active Phoenix particles, and I have given it some velocity, but as you can see, our cubes are still not flying around. So let's go and create a Phoenix FD TP sample node. And when we select it, it will ask for a Phoenix node. So let's pick our Phoenix simulator. And then as an input, it requires position. So let's connect the position of the particles to the position in here. And let's connect the velocity to the direction and to the speed. Now, if we start our timeline again, you can see that our explosion moves our cubes, and it looks really cool. So what does the Phoenix TP sample do? It reads data from our Phoenix simulator, and then it can pass this data along to another TP nodes. In this case, we read the velocity data and pass it as a direction and speed for our cubes. Of course, you can read temperature, fuel, color, viscosity, or speed. And another cool thing that I would like to show you is let's create a float helper in here. Let's connect the velocity, disconnect the speed, and connect this to the speed. This way, if we set it to multiply and set it to 1, we get the control for the velocity data coming out of Phoenix. So if I set this to 0.5, our explosion will be smaller, and if I set this to 5, our explosion will be a lot bigger. And the cool thing with this setup is now, let's set this back to 2, and if I go in here and in the generation, I have already pre-fractured a crate. So if I turn this on, we have this crate, and if we scrub our timeline a bit, you can see that the crate gets exploded from our simulation, and we get this nice destruction effect. Okay, and the last thing that I want to show you is our standalone preview tool. Okay, and this is how our Phoenix standalone preview tool looks like. And in here, we have a timeline. So if I drag it, we can see that our caches get loaded and we can inspect them. So why do we need another external application just to preview files when we have the GPU preview inside of Max or in Maya? The thing is that when you're working with simulations, sometimes the scenes get quite heavy, and loading big scenes with all the interaction geometry just to review a simulation gets quite taxing to your PC, and the DCC application's report performance goes only so far. So this is the reason we have created the Phoenix standalone preview tool. Using it, you can preview Aura, VDB, or Field3D cache files without even loading them into your DCC application such as Max or Maya. And while we are not being bound by the viewport limitations of the host software, we can display a lot more data faster, which ultimately results in being able to load larger cache files and really smooth viewport experience. So in here, what can we do with the tool? We can change the frame from the sequence. We can switch between the GPU preview and the regular voxel preview. And a really great addition to the standalone preview tool is the velocity streamlines option. Using it, we can get a really nice and accurate representation of how our velocity data looks like inside of our simulation. And in here, we can change the colors of the preview. And as well, we have an alternative display method, so we can preview the cache files even better. Of course, if you need it, you can increase the detail reduction or decrease it to get a more accurate representation. Or of course, if you need it, let's turn on the smoke, you can get just a slice of your simulation. And after you've done and you have inspected your simulation data, you can just save it to a sequence in here from this button and preview the entire cache simulation. Okay guys, so thank you very much. That was everything that I wanted to show you for today.